So, good morning. My name is Corinne Miles, and I will be going over segment 2 of behavioral neuroscience. The first title is about the integration and transmission of information. It talks about the neural anatomy of an axon. So, I like to think of it as looking at my hand, and my wrist would be the axon hillock, which is a cone shape that originates outside the cell body, and my palm being the axon and my fingers being the axon collaterals. And everyone knows for a fact that neurons communicate with other neurons through synapses. The communications could be very fast or it could be very slow. If it is slow, it occurs inside the axon. If it's very fast, it occurs on the outside of the axon. The next part is about glial cells. There are 4 types of glial cells. The first one would be an astrocyte, which is astro in Greek is star. There's many of them. They have like sucker-like ends that provide nutrition to the nerves. They directly communicate with other synapses and monitors their activities. They communicate with other glial cells to modulate neural responses, and they are involved with formation of new synapses. The second is microglials. They are very small and they are very active. They're like the little army that's in your body. So when your neurons are damaged, they form a spherical containment zone around the injury or disease. They are the key component in pain systems, and they do maintenances on synapses. They are also associated with the development of Alzheimer's and other dementias. The third and fourth one are the oligodendrocytes and the Schwann cells. They are related to myelination. So myelin is a fatty insulation around axons, which allows for the speed of impulses. So if your body needs to send a message, it'll jump from a myelinated sheet to another myelinated sheet over the nodes of Ranvier. If it does end up hitting the nose of Ranvier, it just goes slower. But once it hits the myelinated sheet, it speeds right back up again. The next thing it mentions is that glial cells will continue to divide 10 to 15 years after birth. And because there is a continuous division, it does have a tendency to form tumors. The astrocytes respond to any type of injury in the brain. It's known as an edema, and edemas are responsible for brain injury symptoms. One example of a disease is called multiple sclerosis, which is the degeneration of myelin. It can cause short circuits and loss of information. The next part is the nervous system. It talks about the PNS, the CNS, the ANS. So briefly, I want to go over the peripheral nervous system. Includes all nerves outside the brain and the spinal cord. The central nervous system includes the brain and the spinal cord. The PNS mostly focuses on the motor nerves and sensory nerves, so you can always remember motor nerves as motor moves muscle, MMM, and sensory, it conveys neural activity from the periphery into the CNS. The nerves can be divided into 3 segments: the cranial, the spinal, and the autonomic nervous system. Your cranial, just think of your brain. It's located inside your cranium, so it connects to the brain. Spinal cord emerges from the spinal cord, and the autonomic nervous system. As inappropriate as this sounds, this really helped me in anatomy and physiology my senior year. So the autonomic nervous system, known as the ANS, helps your anus. I know it's wrong, but it worked for me. So I just wanted to teach everybody a mnemonic device for remembering your cranial nerves. It's OOO, to touch and feel very good velvet, such heaven. That should help you remember all 12 of the nerves located in the head.